Dear students, in the last lecture I told you a brief idea about the interfacing of 8259. Okay, how 8259 can be interfaced with the 8085. So I told you about the signals, address bus, data bus and control bus. Okay, because this is an IO chip, so IO read and IO write signal will be connected to this chip. Okay, and this is the data bus. This is bidirectional, through which MUPI can send the initialization command as well as operational command, and this 8259 can send the ISR address whenever MUPI asks to that. This is called the address bus. This is purely address bus. This is multiplex address data bus that will be separated or demultiplexed by this latch. Okay, after 1T state, this latch will provide this lower address, and here the data will come through this data bus. Okay, so only this A0 pin will go into the 8259. If this pin is 0, then it will give the ICW1 and other commands, and if this pin is 1, then it will give the IC2, ICW2 and other commands. Okay, so this was the brief idea which I had given you in the last lecture. Now we'll do the address decoding. This is the most important pin, chip select. Okay, so whatever signal will come over this pin, that should have the value 0, then only this chip will be selected, because an active low signal. Okay, so how we connect this chip select signal to this decoder? Okay, so here I have taken one decoder, so I have given IO oblique M bar, read bar and write bar, and through which I can provide the IO read and IO write, memory read and memory write and other signals. Okay, so the same decoder I have taken over here. This is the 3 to 8 decoder. Okay, so what we will do, we will do the IO mapping. Okay, so how we do IO mapping? So IO devices have the address of 8 bits only. Okay, so what 8 bits I have considered? A0 to A7. Okay, we can consider A8 to A15 also, but this is a standard solution, that's why I have taken A0 to A7. Okay, now it is possible that in the question the address of that IO chip may be given to us. Okay, like the address, the question has given the addresses, but if it is not given, then we need to assume the address. So I have assumed that the address for this 8259 is 60. Okay, so what is the 60? How we can expand this address? We can expand this address by using this 60 is 600110 and 0000. Okay, so see here, A7 to A1, these are the bits on the address line, and this A0 bit which is already gone into the 8259. Okay, so when this bit is 0, there are ICW1 and other like OCW2 and OCW3 commands, and if this pin is 1, then this 8259 will get the ICW2, ICW3, ICW4 if required, or OCW1. Okay, so that is the use of A0 pin. So this pin may be 0 or maybe 1, that's why I have written 60 and 61. The remaining bits will remain same, like 0 1 1 0 0 0 0. Okay, so any of the address we can imagine. You can, it is not necessary that you always imagine 60 and 61. Whatever we think about the address, we can imagine that address, but it should be of 8-bit address, and the conjugative address will be used for selecting the 8259. So what we want, that whenever MUPI will release these two address, whenever MUPI will release 60 or 61 address, okay, then only this 8259 will be selected. Otherwise, if any other address will be released, then this should not be selected. Okay, that's what the interfacing is for. So what we will do, we will check the conditions that when this address will be released or this address will be released, then only this 8259 will be selected. Otherwise this should not be selected. For other than the specified address for 8259 that are specified while initialization, for other addresses this chip should not be selected. Okay, so now using this decoder we will put the conditions. Okay, so this is a 3 to 8 decoder, so 8 outputs and 3 inputs. So based on these 3 inputs value, the output will be selected. Okay, appropriate output will be selected. Okay, and these are the pins G2A bar, G2B bar, this is G2B bar, and this is G1. Okay, so these are active low and this is active high. Okay, so what we will do, we can use A7 to A1 bits, okay, any of the three bits over here, okay, but for the sake of standard solution we will take A7, A6 and A5. So what I have used, A7, A6 and A5. Okay, so what is the value? We have assumed that the address is 60 or 61 as based on this A0, which is having 0 or 1 value. Okay, so these are the value 0, 1, 1. So when this pin have 0, 1, 1 means 3, so which output should be selected? This Y3. Okay, Y3 bar, this is an active low, so this Y3 is 0. Okay, Y3 bar is 0. Okay, because this is an active low signal, so whenever this is having 0, 1, 1, this Y3 bar will be selected. Okay, this is the functioning of decoder. We have undergone this functioning various times in the contact classroom. Okay, so whenever this 0, 1, 1, this Y3 bar 0 is selected, and this Y3 bar 0 will be connected to this chip select. I am not connecting right now because there are some more condition we need to put, but what we will do after finalization of this address mapping, we will connect this Y3 to the chip select. So whenever MUPI will release these two addresses, this chip will be selected. Apart from these two addresses, this chip will not be selected. Okay, so I have put the condition 0, 1, 1. Okay, now see, these are the addresses. Now if I took some other address, like I have given 80, so what is the 80? If I expand this address, 1, 0, 0, 0, 0, 0, 0, 0. So what are the three bits which I have taken over here? A7, A6 and A5. So these three bits. Okay, so these three bits have some different value, 1, 0, 0. So if I put 1, 0, 0 over here, then which address will be selected? Y4. Okay, if I put 50, 50 is my address, then the 50 will be, if MUPI release 50, then this address will be expanded like 0, 1, 0, 1, 0, 0, 0, 0. So what are the three initial bits? A7, A6 and A5 are 0, 1, 0. So if I put 0, 1, 0 over here, then Y2 will be selected. But in case of 8259, where we have decided that these are the addresses for 8259, then 0, 1, 1, apart from 0, 1, 1, any of the bits will be given to these signals. This Y3 bar will not be selected, and if this Y3 bar will not be selected, then this chip should not be selected. Okay, did you get this point? So any of the address we will give apart from 60 and 61, this chip should not be selected. But there is one condition. If we give the address 70, then 70 will be having 0, 1, 1, 1 and 0, 0, 0, 0. So for the first three bits are same for 70 as well as for 60. See here, 60 is having 0, 1, 1, 70 is also having 0, 1, 1. So if I put 70, if suppose MUPI releases the address 70, then it start from 7, 7, 0, 0, 0 to 7 FFF. Okay, so that address, for that address also this chip, this Y3 bar will be selected, because at these pins this is having 0, 1, 1. So we need to put the conditions for these bits also. Till now we have put the condition on these three bits also, or these three bits only. Okay, so this is called a partial decoding. We have not decoded it fully. Okay, so for full decoding we need to put the condition on these remaining bits also. Okay, then only we can say that for particular these two address, this chip will be selected. Okay, so what we will do, see here, if I put A4 equals to 0, okay, so A4 value is 1 for this 70 address, because these two are similar address. For A4 value is 1 for this 70 address, but A4 value is 0 for this appropriate address 60 address, which is the address of 8259. Okay, so if I put A4 equals to 0, and A4 equals to 0 means I will connect it to this pin. Okay, this 0 will be gone over here and this will be 1. Okay, so if I put A4 equals to 0, then only Y3 will be selected. Then we can say yes, we have reduced this series of this 7 address of 7 from this decoder, because once if we put A4 equals to 0, then if A4 becomes 1 while we are providing the address starting from 7, then this chip this Y3 will not be selected because it is having the value 1, and this should be this active low signal should have the value 0. So these addresses are cut from our range. Okay, now once this A4 is selected, now we can have the other address, like suppose the address is 62. The remaining patterns are same, 0 1 1 0, but the last 4 bits are 0 0 1 0. Now this is the another pattern, but in this 60 and 61H we are having A1 equals to 0 for both the 60 and 61H. But if we are having 62H, then this A1 should have the value 1. So we will put conditions on all these 4 bits, so that we can say that yes, we have put the condition on all these 7 bits, because this A0 is going inside the 8259, so we need not to put any condition on this A0. Okay, so we will put the condition for A7 to A1. Okay, so now what is the value of A3? A3 is 0, so I can connect the pin A3 over here because its value is also 0, so this is an active low signal, so this will be selected. What is the condition of A2? A2 is 0. Okay, so if I want to connect this A2 over here, then I will use a NOT gate. Okay, I connect A2 whose value is 0 after because this is an active high signal, so after inverting this bit we are having 1, and this 1 will connected over here. So by putting all this condition, we can say that Y3 will be selected and these all are satisfied. Okay, but still we are remaining with one bit, that is A1. Okay, so how we can connect A1? We can connect A1 like this. As A1 is 0, Y3 equals to 0. So we can put A1 over here, A1 equals to 0. Okay, now this is the signal where we can provide this. Now see here, which gate should be used when we are having the condition that output should be 0. Okay, at this line the output should be 0. So which gate I need to put over here, so that I can say that output should be 0 and input should also be 0. Means when both the inputs are 0, then only output is 0. So if Y3 equals to 0 and A1 equals to 0, so AND means we need to put a OR gate. Okay, so OR gate will give 0 only and only when these two are 0. If any of them is 1, then it will give the output 1. So we will use OR gate, and now we can connect this Y3 bar 0 to this chip select. So we can say now that whenever we are having 60 and 61 addresses, then only this 8259 chip will be selected. Apart from 60 and 61, any of the address is there, then we cannot select the 8259 chip. Okay, if we are having 70, then these bits are same, but this bit is different. So when A4 is different, then A4 will get 1 over here and this will not be selected, so this will not be activated, then Y3 will not come out of this. Okay, so we can say that we have put the condition on these pins, and this A0 is inside the 8259, so we need not to put the condition, because when A0 equals to 0, some of the commands IC1, ICW1 and other, and A0 becomes 1, then ICW2 and other commands are selected. Okay, so this is one of the way to get the interfacing between 8259 and 8085. Okay, one more thing we can use, that instead of using this kind of interfacing, we can remove this A0 over here, that we directly connect this to chip select bar. Okay, Y3 equals to 0, but we need to accommodate this A1. Okay, so how do we accommodate this A1? Like we can do, and one more thing, we know that this is an IO chip. Okay, so IO oblique M bar should be this is an IO chip, so IO oblique M bar should be 1 for this. Okay, so what we can do, as see here, A4, A3, A2, A1 all are 0. Okay, so instead of using separate chips for separate pins for this signal, we can use A4, A3. Okay, and then we can put a OR gate. Okay, the value of this pin are 0. So whenever these both are 0, then only this will give the 0. And A2 and A1, we can connect A2, A1. Okay. See here what I am writing, A2 and A1, and then we can put a OR gate. Okay. So how do we put a OR gate? So that whenever A2 and A1 both are 0, then only this will be 0, because both are 0. See here we have put the different scenario for the interfacing, that whenever these 4 pins are 0, then only these two signal will get the 0. Okay. And at this place where we have connected A2 and put a NOT gate, we can connect another pin, because we are using IO chip. Okay. IO chip means IO/M bar signal should be 1, and that one will be connected over this G1 signal. So what we have done, we have used A1, A2, A3, A4, A5, A6 and A7, all the pins, and whatever conditions we have applied over here are the based on this addresses 60 and 61H. Okay. And when Y3 will become 0, when all these condition will be satisfied. At G1 we have connected IO/M bar, and for IO chips to be selected, this signal should be 1, and this signal go to this, and then only this decoder will be enabled. Okay. This G2A bar and G2B bar should get 0, then only this decoder will be enabled, because these are active low signals. So for active low signal we have put the condition using OR gate, that this pin should be 0. So Y3 becomes 0 when all these condition will be satisfied. So for 60 and 61 address which we have assumed, okay, this address may be given in the question, or we need to assume this address. Okay. So we have assumed 60 and 61. Then for these addresses only, this Y3 will be connected to this chip select, and this Y3 will be selected after satisfying all this condition. Okay. And then this chip will be selected. So for these addresses, these two addresses, this chip will be selected, otherwise this chip will not be selected. Okay. So if we are changing this chip 8259, instead of 8259 we are using some other chip, then based on those condition, that chip may also be selected. Okay. I hope you understand this interfacing. Thank you.